everybody. So today we are going to be reviewing chapter 3 as a whole and just kind of going over the main things that we have learned about in chapter 3 before you start the practice test and then ultimately take the chapter 3 test. So during this review, okay, most of these notes you already have down in your notebook. So it is up to you whether you would like to write them down again because remember, muscle memory does help a lot of times, but it's up to you. Okay, if you'd like them in your notes, this is all going to be helpful information that if you have it in your notes, you can use on the test. So it's up to you. Take notes if you would like. I would highly suggest that. But pay attention, watch, and if you have questions, let me know while you're watching this. So the learning target for today is going to be I will be able to understand chapter 3 concepts and main ideas. Okay, let's go right to 3.1, which is algebraic expressions. So in section 1, we talked about like terms, okay? And like terms have to have two things, remember. Like terms have the same variable. And just a reminder, variables are the letters, okay? We call them variables in math language. So they have to have the same variable, and those same variables have to be raised to the same power. Okay, so what that means is, let's do a couple examples. Okay, 2 and 3 are like terms, okay, and that's because these are constants. All right, constants are numbers that do not have a variable attached to them. Okay, we call those constants. Here, I'm going to write and so that we don't think this is a point. So 2 and 3 are like terms. 3x and 4x are like terms, okay? And then 5x squared and negative 2x squared, these are like terms because, again, they have the same variable raised to the same exponent, okay? They're raised to the same power. So that is our rules for like terms. Simplest form. So simplest form is when an expression has no like terms and no parentheses. Okay, so that is what makes something in simplest form. So no like terms and no parentheses. Once you have that, it is in simplest form, okay? So when you're simplifying things on the practice test and the chapter test, remember, cannot have parentheses, cannot have like terms. Okay. So how to simplify an algebraic expression? Well, there are a couple steps you're going to want to follow, okay? The first step is you're always going to want to rewrite it as a sum. Rewrite as a sum of terms. And what that means is, remember in chapter 1, when we said to subtract integers, add its opposite. So that's what we're going to do. So we would write this as 9x. Rather than the subtraction sign, we're going to write plus negative 2 plus 7. And then rather than the minus x, we're going to write plus negative x. Okay? So that is rewriting as a sum of terms. Okay, the next thing that I'm going to want you to do, we've talked about this a lot in this chapter, is identify your like terms using shapes. Okay, so I'm going to put a square around 9x and negative x because those are like terms. They have the same variable and raised to the same exponent. But you're probably thinking, there's not an exponent there, Miss Hayes. Well, there isn't, but if a variable does not have an exponent, we can always assume it's to the power of 1. All right, and then I'm going to put another shape around my constants, which remember, constants are numbers that don't have a variable attached to them. From here, if we want to simplify it, we want to rearrange so that our like terms are next to each other, okay? So I'm just literally rearranging so that if I were to put the boxes around them again, the same shapes would actually be next to each other, okay? And now, again, paying very close attention to signs, okay? And we can use calculators, remember, so use your calculator if you're ever confused. 9x plus negative x, that's going to equal 8x, okay? And then negative 2 plus 7, that is going to give me a positive 5. So 8x plus 5 is my simplified version. As you can see here, there are no like terms because if I were to use my shapes again, there's only one of each shape. So I know that all my like terms are combined, and there's also no parentheses, okay? So that's the most important thing that you need to do when you're simplifying an algebraic expression. And this goes into 3.2. So adding and subtracting linear expressions. So just a reminder, a linear expression is an algebraic expression in which the exponent of the variable is 1, okay? The exponent of the variable is 1. So a linear expression, as you can see, it does not have an exponent, okay? And remember, if it doesn't have an exponent, we know it's to the power of 1. These are not linear expressions because they have exponents that are greater than 1. All right, so now let's take a peek at example 1, adding linear expressions. So let's just quickly go over the vertical and the horizontal method. So I'm going to do the vertical method in blue. So for the vertical method, what you are going to do is you are going to stack your like terms vertically and then just add. So first, I want to actually identify what my like terms are. So I'm going to circle my x's and then I'm going to square my constants, okay? And then what I'm going to do is I'm going to stack them on top of each other. So it's going to be x minus 2 on top plus 3x plus 8. Notice I'm careful about carrying over whatever sign is in front of the number. If it's a subtraction sign in front of the number, you gotta make sure you actually include that, okay? Because that's going to change the signs. All right, then we just add. If you have a variable and there's no number in front of it right here, there's no coefficient, what can we assume that coefficient is? Well, we can assume it is a 1, okay? And then remember, when we're adding those together, it's just essentially going to be 1 plus 3, and then you're going to attach your x at the end. So that's going to give me 4x, and then negative 2 plus 8 is going to give me a positive 6. So that is the vertical method, all right? The horizontal method, similar to what we did above, but the horizontal method is going to be, well, first rewrite it as a sum of terms, okay? So I'm going to write x, rather than writing minus 2, I'm going to write plus negative 2, and then plus 3x and plus 8, okay? Again, we always need to identify our like terms, so I'm going to circle those, and then I'm going to square the constants. Then what I'm going to do is I'm going to rearrange so that my like terms are next to each other. So I'm going to do x plus 3x plus negative 2 plus 8. Notice that I did not drop the negative sign that's in front of that 2. Okay, you got to make sure to carry it over whenever you're moving things around. All right, again, I'm just putting my shapes around it because it's a great way to keep track of your like terms so you know what to combine. Now, we just combine them. So that's going to be 4x. And this right here is going to be plus 6. And that is my final answer. So notice, you get the same answer either way, okay? It's up to you which method you prefer to use. All right, now let's look at subtracting. So the biggest thing that we want to remind ourselves about, finding the difference, is this subtraction sign changes everything, okay? So what I taught you in 3.2 is that I want you to actually distribute it in to each of the parentheses first, okay, before you go any further so that you pay attention to it. So for example, we have 5x plus 6. If you are subtracting a negative, because this is a negative x, what does it turn into? If you are subtracting a negative x, what will it turn into? Well, I hope you're thinking a positive. That is going to turn into a positive. Then a negative and a positive, well, if you're just subtracting a positive number, it's just going to be minus 6, okay? So that is what it's going to turn into when we distribute the subtraction sign. Then once we have it here, we do the same old thing. We identify our like terms, okay? And then you get to choose, do I want to use the vertical method or the horizontal method? And that's totally up to you. But the main thing with the subtraction sign is that you got to distribute it into the parentheses first. So similar situation here. You need to distribute it into the parentheses first. But this time there's a number. So I'm going to show you how to do this. So 7y plus 5 will stay the same. Then you're going to have minus 2 times 4y. So we're distributing that negative 2 to the first term in the parentheses. Then you're going to have negative 2 times, don't forget that negative sign in front of the 3, negative 3. Okay? You multiply those out, all right, when you distribute. Negative 2 times 4y is going to give me negative 8y. And negative 2 times negative 3, a negative times a negative, always going to give me a positive. So that's going to be a positive 6. Okay? From here, now again, I identify my like terms. Okay? And then once I identify my like terms, I can choose to either do the vertical method or the horizontal method like above. Most important thing about this is if there's a number outside of the parentheses, you gotta distribute it in first. That is always your first task. All right, let's scroll down. So solving equations using addition or subtraction. Remember, look over here. Addition and subtraction are inverse operations. That means that they cancel each other out. So let's peek here. When we're solving equations, you always want to look at the side with the variable on it. Look to the side with the variable on it, okay? The next thing you want to do is you want to decide what is attaching that 5 to the x. Well, I see the thing that's subtracting that 5 to the x is subtraction, okay? Which means I have to do the opposite operation, the inverse operation, which I know is addition. So we draw the line down the equal sign, okay? We add 5 to both sides, okay? That equals 4. X equals 4. So you see, we see subtraction here. Immediately, we add 5 to cancel it out, okay? Because I know negative 5 plus 5 is going to be 0. All I'm going to be left with is x. Don't forget the check, okay? You start by writing the original equation, the OG equation. Then you plug in what you got x equals right here. So 4 and 4. Then you simplify it down to see if it actually equals what that right side does. If it does, you know your answer is right, okay? So same thing over here. You want to look to the side with the x on it, okay, or the variable. So this is a z, but it's still the variable, so we want to pay attention to that side. Then you want to see how is that number being attached to the z? Well, I see that it's being attached through addition, okay? And what that means is I'm going to need to undo it with subtraction. So look here. I subtract 3/2 on both sides. I make sure to draw a line down the equal sign because remember, the algebra rule is whatever you do to one side, you must do to the other. All right. So that is your algebra rule, okay? Again, same thing. You always got to check your work. I will be expecting this on your practice test as well as your test, okay? Check your work to see if you were right. So that is solving equations using addition or subtraction. Now we're going to take a peek at solving equations using multiplication or division. And again, it's similar patterns. So remember, multiplication and division are inverse operations as well. So what you're going to do, you're going to do the same steps. You want to look at the side with the variable on it. So I'm going to look at the side with the variable on it, okay? So x over 3. If you see a fraction, okay, the operation that is making that a fraction is division, okay? So in order to undo division, what operation do we have to do? Multiplication. So you see here, we're going to multiply by that number that's in the denominator, which is 3. So we multiply both sides by 3, okay? That is going to ultimately isolate the x and give me my answer, which is negative 18. But I don't stop there because I still have to check my work. So again, you write the OG equation, okay? You plug in what you got x equals, which is negative 18, negative 18. You simplify that left side and see if it equals the right side. If it does, you know your answer is correct. Let's look down to B. So B, again, oh, look at this one. The variable's on the right. So don't get in the habit of always thinking the variable's on the left because it's not always that way. So the variable's on the right, okay? So we want to pay attention to the right side. So if there is a number that is attached to the variable, okay? Attached to the variable, it's connected to the front of the variable. What attaches the number and the variable together? What operation attaches them? Hopefully you are thinking multiplication, okay? And since multiplication is what is attaching it, in order to undo it, we need to do division. So if you look here, we are going to divide both sides by 4. And remember, in algebra, the way we show division is not with this division sign. We never show it with that division sign. It's always as a fraction, okay? Okay, so you divide both sides by 4. Those cancel out. You're left with y equals, and then you do 18 divided by negative 4, and you get negative 4.5. Again, same thing as above. Plug in what you got for y into that original equation. See if it equals that left side. If it does, you know your answer is right. So that is 3.4. And then finally, with 3.5, solving two-step equations, you're going to piece practically the whole chapter together. And the rules are for this is, the first rule is you are going to want to undo anything not attached to the variable. Okay? That is going to be addition or subtraction, always. The second thing you're going to do is you are going to divide or multiply to isolate, which means make that variable by itself, isolate the variable. Okay? So first thing you want to do is always do the stuff that is not attached to the variable. So let's look at this. We still want to pay attention to the side with the variable on it. So we're going to look at this side, okay? The left side. Then I don't want to pay attention to the variable quite yet. I want to pay attention to, is there something being added or subtracted next to the variable? And there is. There is a plus 5 next to that negative 3x. So I want to deal with that first, and I want to cancel that out first. So you see here, in order to cancel out addition, we have to subtract 5 on both sides. That is my first step. I subtract 5. Then I'm left with negative 3x equals negative 3, okay? Now this is just a 3.4 problem. I see negative 3x. In order to undo that, I have to divide by negative 3 on both sides. If I divide, that is going to give me x equals 1. So these are two-step equations. First, deal with anything not attached to the variable, so addition or subtraction. From there, then you're going to do your division and multiplication to finish out the problem. And then, of course, you always, always, always want to check your work. And when you check your work, you should only be really manipulating the one side that you plugged in that x to, okay? And you need to show all the steps to see that it actually equals what is on the right side. All right, that is our chapter 3 summary, okay? If you have questions, email me, let me know. We're going to practice all of these skills in a practice test in the next couple days, so stay tuned. Thanks for watching.